What's going on, folks? It's Mike here, and in the SDL series today we're going to be talking about the game object. So with that said, let's go ahead and dive into our lesson here. So what I want to go ahead and show or talk about is just what is a game object. And I'm going to go ahead and show you from a popular game engine, Unity 3D, the GameObject class. And in a sense, a game object is just anything that you can use to represent something in a scene. So we can think of, again, each window as a scene or an environment in our game, and then all the individual objects that move around or interact. But it could also be things like lights, it could be cameras in our scene. It's really just any sort of entity. So sometimes you'll also refer to this as not the GameObject class, but the GameEntity class. And just to give you another documentation from the Phaser game engine project, you can also see that it's typically some sort of base class which other objects are going to inherit from. Again, it's just the sort of default entity that holds properties of all your objects. So it is worth noting sometimes that it can be useful to go ahead and look at some of the documentation of other game objects, and that might help you give an idea of what kind of things game objects have, like whether they're active, visible, maybe it holds positions, or all sorts of things. Now, I know something that you may be wondering when talking about game objects. And depending on if you've used other engines like Unity, you might be wondering about entity component systems and how to design them. So here's just a few articles that you can search on Google, the titles here. I just want to flip through. We'll talk about entity systems at a later date, just so that you can have an idea of what they are. I found that these articles are pretty good. So again, you can just Google Autodesk and data-oriented entity systems here and be able to find these. Or even maybe why we don't want entity component systems. It's worth taking a look at. And that sort of falls into the data-oriented mindset for performance. Now, I'm going to go ahead and close this though and just tell you that for this series, let's just start with getting a game object. And what that'll exactly mean is, again, we'll just have some game object here. And it'll essentially be a holder class for holding a bunch of different properties that some object or entity should have. In fact, I might even change it GameEntity just so it's a little bit more generic, or I just tend to like that term a little bit better. So with that said, let's go ahead and start designing it. And I will be a little bit careful here, and we might do some more iterations, just a forewarning, because it's very tempting to have this sort of game object class and just start adding positions in it, maybe names, IDs, all sorts of things. And if you've done a good deal of object-oriented programming, maybe you're familiar with some of the solid design principles and the idea that this should have a single responsibility. So eventually that's what I want to strive for, that this is sort of just a holder class. But when it comes to making games, let's just focus on that for now and go ahead and get a first iteration of our game object. All right, so if you're joining this series and new, you might not have seen our previous abstraction, so I just want to go ahead and give you a quick preview of our code here. This is our structure. We've got a few different sprites and sprite sheets here to handle animation, some associated classes. We also have a resource manager for loading all of our images to make sure that we only load one at a time. And we have our app, which was the abstraction in a previous lesson that we had, just for wrapping around SDL2, our main application there. So let's go ahead though and add to this abstraction a game object class. Okay, so what I'm going to go ahead and do here is go ahead and split my window and go ahead and start with our textured rectangle and our source here. Because this is the type of thing that I do want to actually refactor and perhaps make it a component or something as our game object. So I'm going to go ahead and leave that open while I go ahead and split my screen and start writing the interface for the game object. So let's go ahead and set our defines, or rather our header guard here. And I'm going to make this game object, end if, and create the game object class, or as I'm going to call it, GameEntity here. And we'll have to have some things that are public and perhaps some private data members. Okay, And actually, it's a little bit more useful if I open up the interface for our rectangle here, just so we can see it on the right side here, so that we can see the different portions or parts of our textured rectangle. What I really want to refactor here is this idea that a textured rectangle is just going to be a rectangle that holds, say, an image. So we can think of this as a sprite instead of just a textured rectangle. And we might even want to move or abstract some of the ideas of handling collision, again from our previous lesson where we were able to detect collision detection, into its own sort of component for our game entity. So let's go ahead and just start with the GameEntity class wrapper. And I'll make this a little bit bigger just as I sketch things out so you can go ahead and see. Let's go ahead and start with a constructor here. I'm going to write it all in my header file for now, just so that it becomes clear here. Okay, so every game entity that we have should probably have some sort of textured rectangle here. And again, that's what I want to sort of abstract out here. But for now, let's just go ahead and create a textured rectangle here. And I'm going to go ahead and make this a pointer for now. And I'm just going to call this sprite. And the idea is, or the reason why I'm making this a pointer and not just a regular textured rectangle is, well, maybe every game entity doesn't necessarily need a textured rectangle. So if I do need this, I'm going to have to initialize it. So maybe that can be a function that we use, or perhaps something that's passed into our game entity. And depending on how we want to set this up, we could make that as part of our constructor here. For now, I'm going to make sure that this is initialized to null, just so it's set there. And I'll go ahead and create another constructor here that will take in our textured rectangle. And let's go ahead and think about how we might want to structure this. And we can structure this by either passing in a string and sort of matching our constructor here, and then creating it, or by taking in an actual textured rectangle, making a copy of this object, and then passing it in. For now, I think it probably makes sense to just take in a string and call this the sprite path. And then what we'll go ahead and do is create a new sprite here, which is a textured rectangle, and go ahead and take in the path here. And we also need the SDL renderer here. So I'm going to go ahead and pass that in here. SDL renderer. Okay. Now, since I'm passing in this pointer here, I probably do want to store the address of this render so that I only have to do this once on construction. And if we do need to change the renderer for some reason of where the entity is actually rendering to, then we can have an update renderer or something member function. So let's just go ahead and store that here. So SDL render, and I'll be a pointer, and I'll store the renderer here, just so we only have to do this step one time. Render. And since we're passing this copy in of the renderer here, or the pointer, which holds the actual address of wherever our actual renderer is, that's what's being pointed to or copied over here. So we should be good to go there. And now my textured rectangle can use the renderer and load the appropriate sprite path here. All right, let me add a semicolon here, make sure I terminate everything. And then our entities are probably going to need generic update and render functions here. And this is where I'm going to want to do a little bit of work here to sort of set up and maybe say, update could be things like updating the position of our entity or whatever properties we have. Right now, we don't have any associated with it other than maybe the sprite, but we do have a render function here. I'm going to say if our sprite is not null, and sometimes I like to do these in reverse here, that's a little bit safer, then let's go ahead and on our sprite, then we will actually call the render function here, which is part of our interface. And we have the end renderer to do so. Okay, so this is what our function looks like. Let me go ahead and move it up so you can see everything on the screen at once. Not that we have added too much at this point. And I'll actually just make this a little bit smaller for you. There we are. So you can see the whole GameObject class here. And essentially what we have here is just on the left side of the screen here, a wrapper around a textured render. We might want to add other components, like other things that we can do with game entities, like make these animated sprites. But let's go ahead and just pause here for a moment and then make sure that we can compile now that we've added quite a bit of code here. And I'm going to need to include a few libraries here as well, including our textured rectangle class here. Okay, now where do we actually do our implementation? Well, that's where I'm going to open up in source our main.cpp here. And this is what we had last time where we had a textured rectangle and an object. So again, let me just go ahead and run this just so you can see here. And looks like I didn't build last time. So let me go ahead and just build. You'll see the compile command on the bottom here. And looks like our program has successfully compiled. And we just had these two textured rectangles that moved around, and when I left-clicked, it detected if there was a collision or not between them. Okay, so let's see if we can essentially do the same thing, but this time using our GameEntity class instead of just pure textured rectangles. Okay, so I'll start refactoring the code on the right side of the screen here. Instead of using a textured rectangle, I'll use my GameEntity here. Let's go ahead and create two. And let's see, for now, I won't worry about handling the collision yet. I'll get to that portion here in a few moments. So let me go ahead and get rid of that. And we don't have a draw function to set their position, so I'm going to go ahead and hide that. But I do have the ability to render each of these objects here. So instead of creating a new textured rectangle, this is going to be a game entity here. And we need the renderer and the file path. So we have a constructor for this, game entity. And we have our associated callbacks here, which are going to be called every step of our loop. And that should be it. So let's go ahead and run this here. See if we made any mistakes. And a few mistakes here. Let's see what we have. Looks like I've just forgotten to include the header file. Include game entity HTTP. Or this is actually game object. Let me actually just go ahead and rename that because I wasn't sure exactly what I'd want to do there. So that's in my include folder here. So I'm going to move game object and just call it game entity. You'll hear either one commonly, and either one is equally valid. Okay, let me open up again our game entity and split our screen so that we have our main here. Okay, let's go ahead and try to do a rebuild here and see if that's been fixed now that we have our associated game entity here. And because I'm now storing the actual render as part of the object, I can get rid of the renderer here. So we're just going to be able to follow this API here. That's a little bit nicer. It's just less code when we're actually doing the game programming here. So I actually like that for now. So let me go ahead and simplify this. There we are. Get rid of that. That's also one less call, so we have a little bit less overhead in our application now. We just say, hey, render the thing, and for the most part, we'll only have one window at any given time. And it looks like I have a little redefinition error. So this is actually, looks like it's been a problem in some previous code that I've had. So let's go ahead and fix that up. Looks like I didn't have my header guards here. And that can cause quite a problem here. So by convention, I like to make these all capitalized, so it's a little bit easier to see them. And make sure I have the end if here. And that way this file will only get included one time, so we don't have to worry about that there. All right, let's try to build again. And let's see what happens here. Okay, looks like we have our build. We can run our program, and nothing's showing up. Well, why is that? Well, we probably don't have a default position for any of our objects. So again, that's something that I can handle by either adding as part of my game entity some abilities to set the positions of my textured rectangle, or let's go ahead and make sure in our textured rectangle here. Let me actually split this one more time. I'll do this in the source, that we are actually setting some default positions here. Because I never set the default position here, I only do it if there is an actual draw call, rather than in any of the constructor. So by default, we probably always want to set default values here for each of these here. And I'm actually going to set these just to what I will call reasonable defaults, but you might decide something else. So 0, 0, and say 32 by 32. And it could be important to do this type of thing. We could have dove into our debugger to maybe see what was happening. And I think that would be okay. Let me actually handle one thing that I just noticed in the code here. I said if our, we want to say if our sprite is not equal to null here, then actually to do the actual render. So let me just do a rebuild here. And anyway, so we could, again, try to use GDB or these kind of things to figure out what's going on. Now here you'll see in the top left corner, we have our two objects. They're actually rendering on top of each other, so we only see one at this given time. And they are quite tiny. That's our defaults that we gave here. So what I'm going to go ahead and do is now change our API a little bit for the rectangle that we have here. Because it's a little bit awkward how we have this set up with this draw function. You know, this is really a sort of set properties type of function. And I probably want to be able to change the X and the Y individually for the position or the region at which we're rendering some shape. And the width and the height are really separate properties. So these really need to be different components here. Now, my question is to folks, and they can sort of think about this as design here, is should I be doing this in the game entity where I sort of give access to the ability to change some of these properties, or should I handle all of this in the textured rectangle? And I have a surprising answer that it probably may not matter, especially for a small scale project like this. In fact, sometimes you just want to get things done. That said, let's try to go ahead and do things appropriately though. And where can we get some sort of reference? Because I always want to sort of show you how I learn things. And one thing that we can do is actually just look at some documentation of other engines and try to figure out what do they do. So if I quickly look through Unity's game object here, and I want to see some of the different things, like maybe the constructor and different ways to construct objects, well, I don't see anything such as a setter for the X position. So typically the way a Unity engine works is that they will have a series of components that are part of their game engine, or excuse me, their game object. Again, that's part of their entity component system, which is a little bit different than what we're developing here. So an approach, or something that they used to do in their engine for various things, was just the ability to retrieve a particular component, that is, say, the textured rectangle, and then set the properties through the textured rectangle class. And that's what I'm going to opt to do here, rather than having a set X position and set Y position and these kind of things. And the reason is I want to make sure that that responsibility still sort of lives in the textured rectangle. Again, folks can maybe argue about this in the comments if they think one way or the other is more efficient. But I think this makes things a little bit easier if I end up making changes to textured rectangle. For instance, again, figuring out how to draw things and split up that, well, X and Y should probably be changed at a different time than width and height. Again, then I don't have to also update my GameEntity class, which isn't really related to this. So anyway, maybe let me show you in code what's going on here, and then it'll make a little bit more sense. So the first part here is I want to go ahead and change this interface a little bit. And I'm just going to call this set position. And this is just going to modify the X and Y. And this is going to be set dimensions, which is just going to be the width and the height here. So that's what we'll have here. And that sort of speaks for itself here. And let's go ahead and make sure that I also update the interface in our textured rectangle here, such that we're using set position and set dimension instead of draw. And so I'll just quickly do that here. And let me get rid of a few of these things here. And let's go ahead and just indent this. And there we go. So now we no longer have draw. Okay, and now in our GameEntity class here, I'm just going to have a public member function, and it's just going to return a reference to this actual sprite here. So I'll just call it something reasonable like get textured rectangle. Again, I might want to rename this component actually to sprite. I think that probably makes sense, but for now it's a textured rectangle. And this is going to allow us to just return that particular component here. So what am I returning? Well, I'm returning mSprite. And that is a pointer here. Textured rectangle, a pointer there. Now, actually, I should be a little bit careful with this because I am actually returning the actual sprite that we have here. So I could actually dereference this, and I probably want to return the actual reference here. So we get the actual, again, textured rectangle here. And now once I get the textured rectangle, then I can set position and set dimension. Okay, so let's go ahead and first just see if this compiles here, see if I've made any mistakes. A couple mistakes here, as always. So I need to return my types here in my class. Make sure that those match because these are void here. And I'll do another quick recompile. Again, just fixing one or two things at a time and then trying to rebuild. And again, there's a build. And let's go ahead and now try to use our API. So I'm convinced that I have set position and set dimensions. And let me go ahead and close this out. And let's go ahead and open up our main. And I'll just go ahead and open it here. And in our render function, I can either do this in the render function or where we are really doing our updates. Say if I'm moving the mouse position around, for example. Let's go ahead and just set some reasonable defaults for now for the positions. And actually, let me do it just right here where I was previously drawing object 1. So now what I'm going to actually do is get the textured rectangle and then call set position at 50-50. And let's go ahead and do that same thing. Let's set the dimensions. And we had it at 100 and 100. Okay, let's go ahead and give this a compile. And then I'll start getting ready to do object 2. And again, just missing a few parentheses here. Oops, there we are. All right, so that's good to go. And since that's good to go, I can copy and paste, always a risky operation, but there we are. And basically for this demo, I just want to show that these are in different places here. So let's just go ahead and move it about 200 by 200 here. There we are. And then I'll go ahead and give this a run. And now that we can see, we have our two different objects here at different positions and dimensions. So we're good to go there, and it is working. Now let's handle this last part where we have the collisions here, so that we have that functionality back here. And what we're going to have to do is perhaps change our interface a little bit here, in the sense that, well, actually we don't have to make too many changes here. Just for each of our objects, we just have to now call get textured rectangle dot is colliding, and then test with the object here. So let me go ahead and clear this. And actually, I want to be a little bit careful here, because when we're doing the object to get textured rectangle here and checking our collision, we're checking against a game entity here. And we'll have to think about this a little bit, because each of our objects have a textured rectangle, which has sort of a bounding box around it, another rectangle. So what I'll actually have to do is, for this object, actually get the textured rectangle here. And let me actually check here how that works. So we have, we're checking if it's colliding. So we actually want to get the actual object here. Okay, so let's try to build that here. All right, one little error, and we are actually returning the reference here when we get the textured rectangle, which matches when we check if something is colliding. So let's go ahead and just rebuild that. And now if I run our little program here, if I click, well, it's not moving to my mouse. So every time I click, it's just not colliding here. So let's go ahead and do one little update here, just to go ahead and finish this lesson off, where I'll move or set the positions to my mouse. And again, just as a reminder, or if you're following along in this series, let's go ahead and look at our SDL app class. And we have functions for getting the mouse X and the Y position here. So from our app, we can get mouse X, and from our app, get the mouse Y position. One more rebuild here, and we'll go ahead and run, and we'll see we're back to where we are, and I can left click again and check if we have collision. So at this point, we pretty much have enough for a game here. And I want to say that our abstraction is getting actually pretty powerful here. Because again, we have objects that we can move around, we have a way to sort of model them, and we're starting this ability to sort of add components together and sort of build these different entities that we have. Now, of course, we've just added sort of a layer of abstraction on top of our textured rectangle, but now we have this holder class game entity, again, where maybe we can build more powerful things. Maybe we'll have next a collision component, because maybe we won't want some of these sprites to be able to collide. And maybe we'll be able to automate or have some managers that just take care of some of this for us. So we've got a lot of exciting things that are coming up in this series here. So I hope you've been enjoying. I hope this was a useful introduction to just thinking about how you might structure your game object or game entity classes. And if you've been enjoying this, please go ahead and like and subscribe, because, well, there's plenty more to come. Thanks for your time, folks.